Hello again, and welcome to another Digital Differential Equations lecture video for Salt Lake Community College. In this video, I'd like to continue exploring numerical solutions to differential equations. This is the third video in this series. To start with, we were looking at how to compute numerical solutions to differential equations using Eulers' method. In that first video, I also presented the modified Eulers method to improve the accuracy of our numerical calculations. In this video, I would like to show you how to use Microsoft Excel to improve the efficiency and improve the accuracy of our numerical solutions using modified Eulers method. So let's go to Microsoft Excel. In our second video, I showed you how to create a spreadsheet and a table to approximate the solution of the differential equation y prime equals y plus 1, starting at the initial condition y of 0 is equal to 1. And we created a table to create our numerical solutions and to compare Euler's method to our exact solution. Okay. In this video, I would like to expand on that table that we already created to now include modified Euler's method. So to do that, let's go back to our previous spreadsheet and let's insert a couple of extra columns. Now, the way I'm going to insert these columns is I'm going to go up to the top of column E, and I'm going to right-click and add Insert. And I'm going to add 2 columns here, so let's insert another one. In these 2 columns, I would like you to insert the modified Eulers method. Now, to make things look pretty, one thing that you can do in Excel is to combine 2 adjacent cells next to each other. So if you'd like to grab these 2 cells and go up to the top, you can merge and center. And so that turns this into just one cell. Now, what I would like you to do in these cells is enter in your formulas for modified Eulers method. So your modified Eulers method formulas is going to be one that creates your un plus 1, your second point that we talked about, and then it's going to be your Eulers method. So I'd like you to enter these formulas into your spreadsheet. You may have to change the width of your column to make everything look nice. Okay. And since I like making things look nice, I'm going to go ahead and put my borders back on these cells. Outside border. Okay. So the purpose of this video now is to show you how to get Microsoft Excel to compute our modified Eulers method. Now, with our table that we're creating, recall our first row, which is row 10, was going to just house our initial conditions. And so I'm going to leave the first cell in my second point column empty. Meaning this cell right here is not going to have a value in it because there was no initial conditions for u. So let's leave that one blank. However, for our modified Eulers method, our initial condition there was going to be referencing our initial cell. which was our y naught cell, which was 1, which we had in cell C7. Okay. I also want to do one more thing. We had calculated Euler's error in our previous example. I want to add to this and now do a modified Euler error. So we're going to add that value to our table as well. Okay, so let's start doing our calculations. And I already put in my formulas at the top of each of these columns. So in our first column here, the second point column, we need to calculate the intermediate or second step for Euler's method. And we're going to be doing this starting with n equals 0. And so if n equals 0, we're first going to be calculating u1. And the way I do that is I'm going to enter equal. If n is equal to 0, then we're going to have here y sub 0. Now y sub 0 is going to be our previous step for our modified Euler's method. So I probably should have typed that here. Modified Euler. Okay, so it'll be equals. If n is equal to 0, we're going to have y sub 0, which is our initial condition, plus h, our step size, and I want to reference that by using cell C5. Remember, you're going to want your step size to be constant, so put a $sign in there. Times, remember in Excel you must use your multiplication symbol to explicitly say you're doing multiplication. It'll be yn, since we're doing step 0, it'll be y0, which is cell F10 again, plus 1 parenthesis. Remember, the second point that we calculate in the modified Euler's method is going to be calculated using your regular Euler's method. So this formula for u, or un plus 1, should look exactly like the formula for Euler's method. But these values are going to change as they are as we go through modified Euler's method. So these values will not be the same as our Euler's method column D. Now it will be the same initially, but it'll be different for the future points. Now I'd like to use Excel to auto-populate the rest of this column. So remember to auto-populate your columns. Choose the cell that has the formula you'd like. Put your cursor in the lower right-hand corner till you get to the black plus sign, and then drag that down to auto-populate your column. Now initially, these values are going to be wrong, because what modified Euler's method does is it's going to update these values as it computes your actual y values. So we're going to have to leave that alone for a minute, knowing they're wrong, until I go to my modified Euler's method column. The first cell that we're going to calculate in our modified Euler's method is going to be column F, row 11. And I'd like to use modified Euler's method to calculate this approximation, and I want to do it as a formula. So let's start by entering the equal sign. And we're going to be calculating the modified Euler's method when n is 0. And if n is 0, we're calculating y sub 1 in our formula. And we're going to be using y0, which is going to be our initial condition that was in the previous row, plus our step size h, which was in cell C5. Again, I want to make that cell locked by putting in the $sign, times the 0.5 times, a first parenthesis to show how we're doing the average of these 2 points, but then another parenthesis for grouping. Now, since we're doing n equals 0, this is going to be y0, which was our previous y value, our initial condition, plus 1 parenthesis, plus Now it'll be our mu, or our un plus 1. This is our previous y value. This is our second point, though. And so this is going to be calculated here. It's our second point. And I probably should have put parentheses around that. So our second point plus 1. Parenthesis to close that grouping off. Parenthesis to close off my formula we're entering in. And hit enter. So this should compute our first approximation using the modified Eulers formula. Now that we've entered this formula in, I'd like to have Excel auto-populate the rest of this column for modified Eulers method. So remember, take your cursor, move it close to the lower right-hand corner to get the black plus sign, hold your cursor down and drag it down to auto-populate this column. And what you should notice when I let go of the button is it should auto-populate this column and adjust the values in our second point column. So it looks something like that. Now these are the values that we would get from the modified Eulers method. And the second point column is the intermediate step that we use to average our two slopes together, which do no longer match our values in our Eulers method column, even though the formulas look the same. Okay. The last thing I'd like to do in this column is calculate the error that we see with modified Eulers method. And remember, we wanted to increase our accuracy by using modified Eulers method. So what I'm expecting to see here is that we're going to have less error. The way I'm going to do this is I'm going to type it in a formula. I'm going to be equals. It's going to be our modified Eulers method value minus our exact value. Again, initially these agree, so there should be no error. I'd like to calculate the errors for the rest of our iterations. So again, let's take our cursor, hold it in the lower right-hand corner till we get the black plus sign. Left click, hold that button down, drag it to the bottom of your table. And what you should notice now between these last two columns is that the error that we see in modified Euler is significantly less than the error we saw in just Euler's method. Is it that averaging of slopes reduced our error? Now the last thing I'd like to do is include the modified Eulers method in our graphic. To add the third line, the third set of solutions to this, you will take your cursor, bring it close to one of the dots that you have. It doesn't matter if it's one of the dots on your exact solution or your Euler approximation, and left click it to select the data. Then right click on that point to where it says select data. Currently, our graphic is just showing Euler's approximation in the exact solution. We would like to add one more set of data to this graphic. So let's first put in a series name. Let's call this the modified Eulers method. For the x values, we need to put our time values in here. So let's hit the black arrow to select our data. And let's arrow over and let's grab our t values. Notice it automatically enters the values into this cell, plus the arrow to insert them into the table. Select our y values. Let's get rid of those values. Again, hit the black arrow. Let's grab the modified Eulers data values and select the blue arrow again to insert them. This now enters the values in our spreadsheet, or in our table, or in the graphic. And you should see them now showing up in our graph. So what we should observe by this is our red solution was the exact solution. Then we had the modified Eulers method in green and the first Euler method in blue. And you'll notice that the Eulers method approximation is, or the modified Eulers method approximation is dramatically better or closer to your exact solution than just Euler's method. So this is what I'd like you to be able to duplicate. I'm actually seeing one more thing I want to change in our graphic is my labeling in the legend. One says Euler approximation, one says modified Euler's method, and I kind of feel like these should be the same. So I want to change Euler's method to actually say, change Euler's approximation to actually say Euler's method. So to do this again, let's go up and left click on one of our data points and then right click to select data. Let's change Euler approximation. Let's edit that to say Euler's method. And click OK. And OK again. Now I think our legend is more consistent. So we have our exact solution, Euler's method, and modified Euler's method all presented. Okay. This completes what I wanted to show you in Microsoft Excel for letting Excel calculate the modified Euler's method solutions and how to compare them with Euler's method in your exact solution. This video should now give you all of the material you need to be able to complete your Euler lab. I hope this is helpful, and I'll see you in the next video.